Alright, we're going to do statically indeterminate structures. Now this is a whole section that's really an advanced topic, and we're not going to get into it in a lot of statics here, but it's important that I think that you see this and understand it. So let's do this. I'm going to draw, let's do this in black. I'm going to draw a free body diagram that is like so. And I'm going to put its supports here, and I'm anchoring it. So this has no roller bearing or roller supports underneath it. Alright, and we're going to put a force C here and force D here. Okay, and of course there'll be some distances and we got to deal with all that. Now, the only way to really solve this one is to know some things about the deflection of the beam. Okay, and I'm going to explain why this is statically indeterminate here in a second. So let's do this. I'm going to give you this, and I have this force here, I have this force here, so force of C, force of D, but because this is fixed, I have this scenario here. Oh, guess we should have labeled these A and B. I have an A of X and I have an A of Y. And then over here I have the same things. I've got a B of X and a B of Y. Okay? Alright, so here's the dilemma with this. So we know you got to do some of the forces in the Y equal to 0, and some of the forces in the X equals 0. And then in order to help you find some of that, we want to do some of the moments about a point. Okay, well, if we do it about A, set it equal to 0, then we're not going to have enough equations to solve this. Alright, and that becomes the problem with this whole thing. Okay, so let's say now, take this free body diagram and we pin it at both ends. Okay, but now our forces are coming in at some odd angle. Force of C, force of D, and we got A, B. Okay, now in order to solve all this, we are going to look like this. So here's our free body diagram. We have A of Y, A of X, B of X, B of Y. But we now have FC of Y, and we got an FC of X, and we get a FD of Y and a FD of X. Okay, so those are all our forces. Some of these things will be known, some of these won't be known, but what we won't know is the parts and pieces here. So let's do this. We're going to go back to our equations, and we're going to write some of the forces in the X equal to 0. And that's going to be AX plus do this with some logic. So we are going to make this positive direction. AX minus BX, that takes care of my two outer sides, minus FC of X minus FD of X. Okay. I will know, let's do this, we will know that because we can find the components of any force once we know the angles and stuff, but then we don't know these two. Okay, so that's a problem. All right, then we need another equation. Cool, let's go write another equation. So the next equation is sum of the forces in the y. We're going to make vertical positive equal to 0 equal to ay plus by minus fcy minus fdy. Okay, well, we will, whoops, let's do it in red. We will know this. We will know this because we're going to get those from the components of the forces based on the angles. But then we still don't know unknown. Okay, so in a normal problem, we'd go to the sum of the moments now. Well, our dilemma becomes this. All right, so if we do this, let's write the sum of the moments, and then we'll talk about that. Sum of the moments, let's go about a equal to 0. Okay, and we're going to do this as that. Okay, so we got by times some distance, well, I'll call it L. And I didn't do any numbers up in here, so L. Alright, and we'll do this as L over 3, L over 3, L over 3 in between them. Okay, so there's that. Then we have F C of y times L over 3. Alright, and that is positive and B is negative. Should have done that. Plus the F d of y times 2L over 3. Okay, now we can solve that, and we will know this, and we'll know that, we know that, we know that, and we know that. So therefore, when we get all done with this, we can solve for by as a solution. Okay, so we use the sum of the forces in the y direction. We can come up with that. Now, our real problem is we can't solve for the x. Okay, so we'll never get these x directions based on these equations. We need another equation for that. So that's where we wind up going into looking at the deflection equations and getting into some stuff that you'll see in strength of materials. But I'm going to leave it there with this general statement. When you see things that are fixed at both ends and forces are rather complicated in that there's there's angles involved, then we're going to wind up always having this problem right here where we cannot solve for a of x or b of x. So then we got to use deflection equations. So that's a whole other topic. I really want to do with this is just giving an introduction to what statically indeterminate structures are. So if you see them, you know what to do with them, and it's something you will learn in the future. But in this beginning statics course, this is not it. So we are done.